In this problem, we're going to use the structure theorem to obtain an algebraic description of the following affine transformation. So in our transformation, we're going to reflect across the line y equals x plus 1, and then rotate 180 degrees around the point 1, 0. So while we're doing that, we're going to track the images of the standard vectors and our 0 vector. So let's make a little chart here to track our vectors. So we start it with our original, and then we do a reflection across the line y equals x plus 1. And then we do a rotation around the point 1, 0. Let's start by tracking our e1 vector, which starts out as equal to 1, 0. So there's our e1 vector. Now to reflect it across the line, it's going to end up here. So our first transformed e1 vector is equal to -1, 2. And then to do a 180-degree rotation, it's going to end up over here. So you can see here we've rotated 180 degrees around this point here, and we end up with our transformed e1 vector as equal to 3, -2. Now let's track our e2 vector, which starts out at 0, 1. So our e2 vector starts out there. And now for the reflection, our e2 vector doesn't actually change because it's right on the line. So it stays at 0, 1. Now for the rotation, we're going to rotate 180 degrees around this point. So we end up with a vector there. So our e2 vector, our transformed e2 vector, is equal to 2, -1. Now finally, let's take our 0 vector, which starts out at 0, 0. And let's reflect it across the line. So it's going to end up right there. So our transformed 0 vector is equal to -1, 1. Now to rotate that around this point by 180 degrees, it's going to end up over there. So our transformed 0 vector is equal to 3, -1. Now using the structure theorem, we can figure out our matrix for this transformation. So our matrix for the transformation is going to be equal to the transformed e1 vector minus the transformed 0 vector. And the next column will be the transformed e2 vector minus the transformed 0 vector. Then we'll have our vector b, which will be equal to our transformed 0 vector, which is equal to 3, -1. Let's fill out this matrix here. So matrix A is equal to our transformed e1 vector, 3, -2, which comes from here, minus our transformed 0 vector, 3, -1. Our next column will be our transformed e2 vector minus our transformed 0 vector. So then we end up with a matrix of 0, -1, -1, 0. So now if we want to write out what happens to any point when transformed, according to these two transformations, we have our matrix of transformation, and then we hit that by xy, and we add our b vector. We can also write this like this. So we have negative y plus 3. So that comes from hitting this vector here by the top row. So we end up with negative y. Then we add this entry here, plus 3. And then we end up with negative x minus 1 on the bottom, which comes from hitting this vector here with the bottom row. So we end up with negative x minus 1. So this describes how any point would be transformed according to these transformations.